Hi, this is Marcus. Today I explore Shannon information theory and a theory of meaning in relation to superintelligence. If possible, I encourage you to also see my 2021 Summit Talk or my 2017 Conference Talk, as they add more detail. Links are given in the description below. To start, I often call this work natural informatics, subject-object modeling, or just SO modeling. All point to one aim, to expand Shannon information theory with a new approach. To now follow my earlier talks, one might ask, so what? How is SO modeling or a theory of meaning useful? To answer, as this work extends Shannon information theory, its value echoes that of signal entropy, a concept over 70 years old and supporting the entire information technology industry. Signal entropy is so accepted that at times we call it the mother of all models. But despite that success, it remains incomplete, which I cover in earlier talks. Still, if we see signal entropy and SO modeling as jointly framing a true mother of all models, they should apply equally to anything we might hope to model, with superintelligence as one likely goal. So superintelligence is this talk's focus, how it might arise and what it might look like. But current AI methods make ideas of superintelligence seem remote, despite claims of a coming machine-human consciousness, singularity, or computer overlords that target humanity. In contrast, I see superintelligence as offering tools for human innovation and discovery. In more popular terms, it frames the thinking needed for Star Trek-like prospects, instead of a Skynet or Matrix-like human downfall. But first, clear hurdles exist. For example, we see many types of intelligence, with diverse species filling varied niches, using knowledge of nature, self, and other to evade mortality. Today, some 8 million such species exist, each with distinct types of intelligence. Of those 8 million species, humans seem to excel, settling niches beyond that of most other species. This requires a type of intelligence on general functions across niches. Humans thus show partial general intelligence in niche diversity, but this also varies widely for humans. So, just for intelligence, no one view exists, with millions of species and billions of individuals in countless roles over millennia. So, to next ponder superintelligence, one wonders, using what as a foundation? Little more than fantasy supports our aims, as we see with most current views. But this changes if we see all agents facing one great natural system, rather than highlighting any one species. What this means is that all life must fit mixed earthly dynamics, where those dynamics in turn suggest a template for general intelligence. This nature-based view is why I call my work natural informatics or thinking like nature. But nature as a great progenitor is also darkly antagonistic. The thing that births and nurtures us strives also to destroy us. Moreover, nature often shifts risk and reward for all species, further clouding one's prospects. So, immediate hurdles to superintelligence are no one view of diverse intelligence types, and life's mixed dynamics, and both with far-reaching effects. For example, with nature setting many adaptive roles, humans lack specific purpose-built tools like fins, fangs, and claws. We instead have functionally ambiguous hands that demand innovation, driving us to invent general and purpose-built tools, as we cannot rely fully on nature's provisions. In that functional ambiguity, we thus find creativity as man-made tools. If not so, we would likely be extinct. Our cultural ecology now holds many psychological artifacts, long ago made into countless useful forms. But our psychological creativity also collides with modern scientific ideals, seen as nature's open systems versus scientific closed or isolated systems, or simply art versus science. Artistic roles use open recombination to refine aesthetic traits and advance new views. In time, all such roles, or aesthetic fits, must abide nature's dynamics, or the agent involved expires. But differently, science names regular, measurable, and repeatable roles to counter ambiguity, but with logical gaps. Thus, one side endlessly probes ambiguity for new possibilities, while the other strives to abate ambiguity, but in a broken manner. Despite that difference, both use trial and error to selectively find more satisfying sense-making, or aesthetic fitness, or more effective and efficient functions. Thus, prior noted diverse intelligence types and nature's mixed dynamics, now alongside broken scientific gaps, all cloud superintelligent aims, but where trial and error and a natural functional aesthetic always apply. This mixing of nature, art, function, and science presents an odd puzzle, where recombinant nature better mirrors art than science, ironic as science arose as natural philosophy, akin to thinking like nature. But this mixed view also marks SO modeling's value, as it holds all roles as complements, not rivals, which makes general and superintelligence modeling possible. As brief review, SO modeling first examines the core of all information, noting a dual subject-object aspect. Next, subject and object support minimal three-part functions for a dualist triune pattern seen in prior talks. As an example, here I show three objects, A, C, and T, used to form two common words, each with specific meaning. But if we ignore meaning, signal entropy of 27 recombinant options arises. This implies meaning exists as a subset of all ACT recombination, most of which lack meaning. This meaningful entropic link between SO modeling and Shannon information theory is what underlies a theory of meaning, which in turn makes the modeling of general intelligence possible. For example, using subject and object as generic logical primitives in place of typical domain-specific material primitives affords a general approach. Material primitives always apply to specific domains, but logical primitives are abstract, meaning they can be universally applied, as with signal entropy. Also, a dualist triune SO logical pattern seen across the cosmos further affirms that general approach. To extend SO modeling further, I now show regular functions and adaptive functions. Minimal regular functions have set objects interacting with other objects as fixed or non-adaptive roles. But adaption has functional variance, where nature's shifts demand new methods. From initially fixed OSO origins, adjacent possibilities arise by shifting subject and object traits. The degree of SO entropic variability seen marks a variance adjacency or remoteness. For example, adjacent minute variants hold a large degree of functional redundancy, key to real-time adaptation. In turn, more remote major variants have little redundancy, creating fatal flaws, chaos, or even wholly new methods, with both followed by many other milder variant roles. Next, of those variants, nature and agent-based forces drive trial and error, selectively framing and revising material reality, moment to moment. Lastly, nothing bars spontaneous parallel selections from adding new branches, while convergent functions also arise to offset that growing complexity. In short, SO modeling starts with signal entropy as a likely mother of all models, and adds meaningful functions and adaptive variants. Evolutionary dynamics that arise from this approach are listed here as a template for general intelligence. It shows small steps onto broad leaps filling material reality, with often nested levels and processes. It marks a new way to view nature and evolutionary trees, which I now show as an unfolding fractal model. Nature ultimately presents a bounded yet ambiguous solution space of many options. Humans exploit that ambiguity, seen as niche diversity and cultural ecology. But beyond this partial view, true general intelligence holds all nature's functions in a contiguous manner, without logical gaps. SO modeling's task is thus to frame true general intelligence without gaps, which would allow us to build even further onto nature's provisions. For example, nature alone cannot explain the arrival of cars, airplanes, and the like. All require human intervention to surpass nature's native features. Our creative drive thus already implies a type of partial supernatural intelligence, born of partial general intelligence. But if we look beyond partial vistas, another worldview arises. In that world, true general and true superintelligence arise via fully realized SO modeling, with a wide range of creative adaptive options. But detailing such a shift is difficult, especially from today's broken partial worldview. To attempt firm predictions here is akin to detailing modern air travel from a view of 200 years ago. Without specific insights, we must instead ask, what similar odd or surprising possibilities confront us today, where we cannot easily differ between fantastic imagining and critical thought? Sadly, few individuals are skilled in such practical creative ingenuity. Still, in that superintelligent future, we can at least say true superintelligence would likely improve material sciences in alloys, composites, energy, and the like, all used to meet many daily needs. Also, new general insights into the cosmos, the world, and humanity would likely clarify some current puzzles. But beyond this, we can say little. I thus leave further speculation to our already active and rich science fiction communities. To close this talk on how superintelligence might arise and what it looks like, true superintelligence offers a wide spectrum of options. Thus, to say a computer singleton will arise to dominate or attack humanity and all life is unlikely. It contradicts prior events. As with nature, superintelligence is so diverse as to defy scientific reduction with its logical gaps and unforeseen hazards. It instead adds a creative narrative that science lacks. SO modeling marks a new path for our information age as an insight engine of eureka moments to augment information theory gains. But still, much work lies ahead, and I plan other talks on practical steps needed to develop true superintelligence and on common fears of a singleton attacking humans. But for now, I stop here. Thank you for your attention so far.